Welcome to the presentation over the cybera internships here. I'm just going to go over different reports. So looked over YOLO V4 and metrics, had different Jupyter notebooks, labeling tools, what other issues, concerns. This is code for YOLO V4 with the COCO dataset, function to calculate distance. There's flags, classes, and different content. Image labeling could be done from RoboFlow, CVAT, LabelMG, Comet. YOLO V5 custom training notebook is listed here. It'll probably give me access to the link because I am the owner. So we can just quickly look at it. So it's kind of cool. We have the release notes, custom training TLO 5, install requirements, assemble the dataset, annotate, have versions, RoboFlow, trainer custom model, value custom model, reference with widgets, and then you just go from there and it builds bounding boxes. And then learn about different image labeling tools, bounding box coordinates, and link with text files, training models, and custom data. Incorporate a function to count number of people passing the area is the next thing. This looks like it's the second sprint, so let's see what's happening here. Or this might be even repeating. Just looks like there's more things that came up here. Comet, Google API, computer vision, TensorBoard. A lot of different information here is model training, model inference, CLI, software development kit, supports. CVAC can be used for object detection, segmentation, pose estimation, semantic segmentation. Has many use cases, some with annotating images and bounding boxes, others with descriptors. LabelMG's graphical image annotation tool, which allows you to draw visual boxes around objects in each image, automatically saves as XAML files of label images, free and easy way to label images. Comment is a machine learning experimentation platform which AI research and data scientists use to track, compare, and explain their ML experiments. It allows practitioners to keep track of their databases, history, performed experiments, and modification models. Google Cloud Vision API uses game-changing, a fully managed development environment, Vertex Vision, to create own computer vision applications or derive insights from images and videos, spin up new video and image and analytics applications in minutes, train machine learning models, classify images using AutoML and custom models, detect objects, read handwritten stuff, easily integrate with BigQuery Cloud Functions and other information. This is showing RoboFlow and how to train the different data set and what the precision and recall was. We also have the custom training notebook. There's a Darwin workflow. There was a community for V7 as well that was kind of helpful and good to use too, listed over here. What else did I learn? Learn about different image labeling tools, bounding box coordinates, link with text files, training models on custom data. Next steps are to incorporate a function to count number of people, figuring out how to create heat maps. This is the next one in November. Learned about heat mapping, benchmarking, Hugging Face CV, and Streamlit CV. This is a heat map for the public data set, and I have a link to the tracking cars GitHub and notes. Process for benchmarking is listed here using YOLO V3 weights and detection. Copy the fixed label image text documents into ground truths. Upload the images from the folder down into object detection metric. Run YOLO model to get the predicted labels from the images that go into detections. Run the object detection metric Python command in terminal, get the map precision put into spreadsheet, and then use this command. Benchmarking is listed here with different information. Different YOLO outputs are listed as well. There's further exploration. We could use Hugging Face transformers, Streamlit library for detecting gender, YOLO V5 for deep sort object tracking of cars. There's also ID tracking over here for different people as well, and different Medium articles. OpenPose can be used to do detection library for body, face, hands, and foot estimation. Simply upload your image or click one of the examples to load them. What did I learn? Learned about ID tracking, depth estimation, heat mapping. Saw how various models compare for YOLO benchmarking. Next steps are to use flags to count number of people and make a polyline for a restricted area. Figure out monocular depth estimation and how that works. This is the next sprint in December. Finished benchmarking, found key differences. There's depth estimation and 3D object detection as well. Lots of GitHub repositories and Reddit posts. These are different depth detection things. There's boosting depth, 3D scene shape, diverse depth constraints, diverse depth, virtual normal, MIDAS, trained on 10 data sets, code for robust molecular depth estimation, and some people are saying that MIDAS is better. There's a code snippet for the depth math for third dimension, prediction with torch, and different prediction model with depth, and there's time and OpenCV information as well, and a Jamboard for the depth math. Further exploration, restricted area marking, counting people with IDs, categorizing height, gender, gait, complexion, object tracking to get the IDs is listed here too, frame IDs, 3D mapping, calculating distances, and point clouds are listed. There were some issues here as well for Python to read the file, figuring out how to use the PIY file, confusing notation monocular, converting 2D XY coordinates into 3D, learned about molecular depth estimation, different libraries for depth function, use triangulation distance between points to find location of objects, combining libraries for heat map, found a video and path of travel. There was a process for depth estimation as well. Obtain a depth map of a scene, which is a 2D image that encodes the distance of each pixel. Convert the depth map to 3D point cloud, which set up 3D coordinates representing the position of each pixel in the depth map. This can be done using the camera's intrinsic and extrinsic parameters, which define the camera's field of view and orientation space. Use clustering algorithms such as k-means or dbScan to group the 3D points in the point cloud into different clusters, each corresponding to a separate object on the scene. For each object cluster, calculate the centroid, which is the average position of all the points in the cluster, gives the approximate location of the object in 3D space. Then calculate the distance between the two objects, calculate the equivalent distance between their respective centroids, and gives the absolute distance between the objects in space. Okay, demo sprint 5 worked on facial recognition detection on Streamlit using media pipe, gave the base code for integration of other parts. Get metrics with frame reach, figure out how to save output as images GIFs, move to pose estimation in Streamlit, try it on Hugging Face for various images. There's a code snippet and demo. I have a pose estimation notebook as well that we can potentially look at. Media pipe and face mesh and pose estimation is listed. You can see media pipe on here. It's trying to do different pose estimations. And this was the Streamlit app that was working. There was also object tracking with the YOLO dashboard. There were some issues with port forwarding in X11, getting CV to write to display video instead of images. And future directions use RoboFlow to train data on object detection, gender, pose, gait, and linking with Streamlit. I learned about pose estimation, mesh pipe, social distancing, object detection with YOLO, augmented startups was a good thing to help get more insight, and then somehow use social distancing code to find distance on people and do RoboFlow training coordination with Streamlit. Okay, and then I'm just going to pause here and then do this in the next video.